Jeff Hammerbacher. Let me just give you a quick background. I studied math at Harvard, went and worked as a quant on Wall Street. The bank I worked for no longer exists. And then I went to, that doesn't identify it very well. Then I went to Facebook, was the first research scientist there, and kind of turned that gig into a whole team of people through the generosity of my boss, Adam D'Angelo, and built a team called the Data Team. It was kind of evenly split between data infrastructure and data analysis. We built a couple of open source projects, one called Hive, one called Cassandra, you may have heard about, and we published a bunch of research papers. More are on their way, I'm sure, from those guys, including one best paper at the International Conference on Weblogs and Social Media. Left Facebook in September of '08 to start a company called Cloudera with a few other folks. And we're kind of rethinking the entire stack for doing data analysis, starting from this powerful open source project, Apache Hadoop. So I'm going to buzz through what Hadoop is, not get too technical, talk about how we use Hadoop at Facebook, and then I'm going to, I just refactored a presentation I gave, which was probably my least successful presentation ever, and hopefully you guys think it's decent. So basically the most fascinating thing to me about Hadoop is not the technology, but the community that has grown around it. And now that I'm on the vendor side of the house, I've been really interested in how people choose to adopt new pieces of software. And also how people just build and release software. So I'm going to kind of talk about some of the sociology behind building and adopting software. And then lastly, I'm going to talk a little bit about, I see these things about like the age of data. And data is great, but none of us set out to collect a bunch of data, so that it's not like we're like miserly, like dragons from Norse mythology collecting data. We actually want to do something with that data, and in particular, I'm interested in understanding and learning from data. So how can we move in that direction? So things that I'm not talking about, and you're welcome to ask me questions about, how to build a team of these people that we ended up calling data scientists at Facebook. When and how should I use data analysis in my organization? Seems very important, but I won't say a word about it today. The growing importance of measurement and intention. I actually believe that storing and processing data has been completely commoditized forever by Hadoop. So the only interesting problems in this space now are how to measure more and how to analyze, where to direct your attention. That's just my opinion, though. Which tools to use for collecting, storing, and analyzing data? Not going to mention at all. If you read Hacker News, I'm sure you get plenty of that. I'm not going to talk at all about statistics, even though I think it's very important. Machine learning, even though I think it's not as important. Data visualization, I think it's very important. Or the whole open data thing, I think that's great. And again, ask me questions, I have opinions. How data analysis is done outside of the web domain. We've got a lot of experience with that at Cloudera. But that wasn't what I was supposed to talk about here. And what big data means for your startup, which is actually, I think, exactly what I was supposed to talk about, but I chose not to. So the whole point of this presentation is on this slide, so you can go back to your BlackBerries or iPhones as soon as I move off of this. I'm just going to read it. The Apache Hadoop community is producing innovative world-class software for web-scale data management analysis. I think by studying how this software is built and adopted, we can enhance the rate at which these data processing technologies evolve. And the best way to do that, I think, is by joining the Hadoop community, because it's open to everyone and it's playing the key central role in the evolution of large-scale data processing and analysis technologies. And you should come out and join. There's a mailing list, there's conferences, there's user groups. So what is Hadoop? You've heard it mentioned a number of times today, so let me give you a little more detail. It's an open source project written mostly in Java. It was inspired by Google's infrastructure. And Google calls their infrastructure kind of software for warehouse scale computers. And that's how I think of Google. A warehouse scale computer is really just a data center full of computers linked in a common network topology. There's hundreds of production deployment of this software. Before I started the company, I probably should have done my research on that, but I didn't. And after starting the company, I was blown away by how many people actually use this stuff. So it's very, very widely adopted. I think the perception is far behind the reality. This is just everywhere in every industry I go to. The project structure, there's two key components of Hadoop. There's a distributed file system called the Hadoop distributed file system. and there is, and that's for storing your bits. And then there's a distributed data processing engine called MapReduce, which you may have read something about. There's also a third major sub-project in the Hadoop umbrella called Hadoop Common, which just has all the kind of client management tools. And there are many other sub-projects inside of this. So we've got a whole menagerie. It's not just this distributed file system and MapReduce engine anymore. It's a whole family of tools. So what does a Hadoop cluster feel like? Well, while we were at Facebook, I used to just order Hadoop servers from my Hadoop cluster in racks of 40 servers. And so we just get in, rack them up, plug them in, image them with operating systems, install the software, and boom, we had more data analysis space. So the standard servers that we recommend to our customers are now 2x4 or 2x8 core CPUs, 8 to 16 gigs of RAM, 4x1 terabytes, 7200 RPM SATA drives, and a couple gig NICs. Usually this is a 1 rack unit server. We've actually seen some larger long-term Hadoop installations moving to 2 rack unit, 12 drive boxes with similar RAM and CPU. But I think this is a good starter cluster for people. The nodes are typically connected in a 2-level architecture. Each rack has 40 servers. You have a top-of-rack switch for the communication between nodes on that rack. And then that switch is hooked up to a core switch, which is talking to each individual rack. And so this is really easy to acquire. Every server vendor can get you a server that looks like this. They're generally referred to as pizza boxes. You get commodity network switches, and you just plug them in. I actually know one company that runs a very large Hadoop cluster up in Seattle, and their ops team is a friend of the family who goes in every 2 weeks and removes the drives out of the back of the servers which have failed and replaces them, and then goes home. So it's this is really, really easy to purchase and maintain. So I took away all the slides about what happens just to give you a flavor of what happens with Hadoop distributed file system. Basically, it's a way to turn those many thousands of servers into a single namespace. So just like on your laptop, you have a hierarchical namespace, /users /whatever. Underneath that, you have all your bits. HDFS presents the same abstraction to you, except it's across 1,000 or more servers. So your clients just interact like they would for any regular file system. There's one limitation to that. Once you write to a file and close it, you can't reopen it and write back into the middle of that file. In practice, for many of the data collection exercises for which Hadoop is used, this is just not really a limitation. And the way that it works underneath the hood is conceptualized via this diagram that my CEO created, and I'm contractually obligated to show in every presentation. Every file is, as it's written, the client takes it, and every 64 or 128 megabytes, it says, okay, the client doesn't know it. The client just keeps writing. But the software underneath the surface says, okay, let's break this into a block. And so that's what the number one is. So the number one is the client takes this file, which you're writing as a stream of bytes, and says, okay, I'm going to make this a block. And then it hands it to the many thousands of servers and says, here, store this block. And the servers say, okay, that's great. And then the servers behind the scene sort of say, this guy doesn't know what he's doing. I'm going to replicate this. And so they take the block and they make as many copies as you tell it to. Normally that's 2 copies. So you have 3 overall copies of this block living on servers, on many different servers. So this protects you, number one, from a server dying. The system will notice that one of those blocks went away and re-replicate it. It also protects you, number 2, from bit rot. There's a process which goes under, so if you store data on a magnetic platter for a very long time, something could happen which would flip that bit. And when you read that data back, it'd be wrong. So Hadoop takes care to perform a hash to execute a hash function on the block before it puts it down on disk and store the hash, so that when it goes back to read it back, it looks and checks and says, okay, this is the same data, that's cool. If it's not, it marks it as dead and you re-replicate and you're good to go again. Third thing that it does, it actually enhances performance. So when you go to do data processing, you've got 3 locations to look at to get your data from. So there's a lot of stuff that HDFS does under the hood. This is a very stable, widely deployed, scalable distributed file system. It's one of the only storage systems that actually works as advertised in terms of linear scaling that I've ever used. I've seen installations with many thousands of nodes running just fine, and it's used to store data from everything from the energy grid in the United States to data coming off a large Hadron Collider to click streams on Facebook. So it's a really widely deployed and stable distributed file system. And then now that we've broken that data up and spread it across those thousands of servers, the next thing you do is you have this engine for processing and retrieving that data, and that engine is called MapReduce. It's also an API for programmers, and all you really need to know know is that the central idea behind MapReduce is to break the work up of a single job into many small tasks, and then execute those tasks as close to the data as you can possibly get. And this is a really nice way to do processing over these large data sets. So that's not all you get. You get this big distributed file system. You get this powerful MapReduce engine, and that's great. But there's so much more in the Hadoop world that doesn't get as much press. One of my favorite sub-projects that we've been working with a lot. So one of the creators of Hadoop is a guy named Doug Cutting. His newest project is something called Avro. This is a cross-language framework for data serialization in RPC. Every major web property that I've come across has something that does this. Google has something called protocol buffers. Facebook has something called Thrift. Avro is really meant to be an evolution of those frameworks that's easier to use with dynamic languages. It's really nice, and we're hosting a hackathon with Dig next week if you want to come write some code. Another thing that is inspired by Google infrastructure is HBase. This is, Hadoop, HDFS, and MapReduce are very good for batch processing. They're not so good for basically maybe serving data to a website or interactive querying. So HBase attempts to address that shortcoming by basically providing the abstraction of a very large table across these many thousands of servers. There's another project called Hive, which I mentioned earlier, that my group built at Facebook. So this provides persistent metadata and a SQL interface to data stored in HDFS. It's also got some columnar storage stuff in there. So this is, if you want to treat HDFS like a data warehouse, Hive basically does that. And we have a number of customers running very large data warehouses using Hive today. And there really is no open source large scale data warehouse, which was weird. It's a weird gap in the market. And so we got this chance to sort of innovate both on the data model as well as just as a data warehouse. So Hive is out there, it's nice. Pig is essentially the same thing as Hive. Zookeeper is a distributed coordination service. It's really useful for hard coordination between many thousands of interacting processes. So quick rundown of what Hadoop does at Yahoo, which is kind of where the primary development of Hadoop took place for the last few years. In 2006, I hired the creator of the project, Doug Cutting. And as you can see, around April 2006, it was pretty slow. It took 2 days to sort 2 terabytes. So luckily, they threw a lot of engineering resources at it, and in 2 years, April 2008, they were able to get the problem of sorting 1 terabyte down to a manageable time of a little over 3 minutes. This was actually a world record at the time. August 2008, they managed to scale their software up to 4,000 nodes. We've got some customers who are pushing it even beyond that size. In May 2009 is the most recent benchmark. So Google came out right after April 2008 and used their MapReduce engine to sort a terabyte faster than Hadoop. So the guys on the Hadoop team at Yahoo worked hard, and in May 2009, they announced that they'd gotten their sort of 1 terabyte down to a minute. So that's a pretty incredible improvement across about 3 years there. And they still hold the world record for fastest sort of a terabyte. And they were even able to sort a full petabyte, which I'm only aware of one other system which can do that, and that's Hadoop's, or the internal MapReduce at Google. And it took them about 16 hours to sort a petabyte of data, which is pretty interesting. They use this everywhere. At Yahoo, there are over 25,000 servers running Hadoop today. So this is widely deployed software across 17 clusters, according to the last presentation. Over 600 people inside of Yahoo use this software every day, or not every day, but have used it. And there are 82 petabytes of data stored across HDFS in Yahoo. So I'll talk a little bit about what we did with Hadoop at Facebook. So when I got there in early 2006, like I said, I was the first research scientist, and the data was stored in a fashion that might be familiar to a lot of folks at startups. It was just a horizontally partitioned MySQL tier. There was absolutely no facilities for offline analysis. We just had a PHP script called Query Runner that ran queries in parallel across these MySQL databases. If you ran a select star, you could bring down the live site. So that was bad. So the first thing I did was I went out and built a set of Python scripts to pull data off of the live site and into a MySQL data store. MySQL quickly fell over and didn't come back up for 3 days. And so actually, I should say that before you throw something out, you should break it and then learn about how you broke it. Because I learned almost everything I know about these technologies by just breaking things and figuring out why it broke. So the second thing we did is, we had some folks who were very comfortable with Oracle then. So the most expedient solution was to get a very large Oracle installation and to start hurtling data towards it. So Oracle held up decently as we were pulling data out of our source databases and storing it offline and doing analysis. But then we wanted to turn on clickstream logging. So for a very long time, Facebook didn't actually log what happened on every click. And so we finally decided to get that turned on somewhere in 2006. And the first day, we got like 400 gigabytes. And our Oracle database was a 10 terabyte database. So we looked at this and said 400 gigabytes a day goes into 10 terabytes not that many times. So we knew we had to do something. And the other problem was we were only able to load 400 gigabytes of data into our database every 26 hours. That's how long it took to get that much data in. And this is 24 hours worth of data. So once again, I did some quick math and recognized that I was going to have issues. So we actually went out, we built our own parallel log file processing engine. We called it Cheetah. It kind of worked. There was a lot of things that it didn't do. And I've seen this at almost every web company. They write a Perl script to parse their data. And then they make the Perl script multi-threaded, and then they make it multi-process, and then they add some fault tolerance, and then they start chunking their data, and they're basically just building Hadoop. And it's just kind of like, stop it, just use this thing. So this is what it looked like when we were doing that with Oracle. So we had Scribe, which was our system for collecting log files, writing data into this database server, and then we went out and grabbed data off of the MySQL tier every 24 hours. And that was great. And I should mention that between licensing and hardware, we probably spent between $1 and $2 million on that Oracle database. And so for about the same price, a little over $1 million, we were able to get several hundred terabytes of storage. So that was for 10 terabytes. We were able to get several hundred terabytes of storage within our Hadoop tier, almost a petabyte, for less than I paid for 10 terabytes of Oracle. And so this allowed me to basically start landing our log files directly in Hadoop. We would pull data out of the MySQL tier in there. And we also had a third data source, which was we did a little bit of web scraping and web crawling and pulled data in there. And so this Hadoop tier just exploded in size. We went from kind of like 0 to hundreds of terabytes to many petabytes in under 2 years.